All right, in this lesson, we're going to learn something that you probably have not seen before, the idea of an identity. Okay? The last few units, we've talked about solving for trig equations. It kind of made sense. You were finding values that made an equation true. A trigonometric identity is a statement that relates two trig ratios and is true for all values of the variable. So in these questions, we're not trying to find out what the variable is. What we're trying to do is show why these are true. And here's the secret. They are always true. If it's an identity, that means they are true all the time. All right, you already know some identities. Here's one. You know that cosecant is 1 over sine. Always. Not sometimes, always. No matter what the value of theta is, that's always true. Same with secant equals 1 over cos. Same with cotan is 1 over tan. Okay? These are all identities that we've already kind of been introduced to. An identity means that they are true for all values of theta, or all values of the variable. What we're going to do is show why or how trig identities actually are equal. So here are some strategies. I'm going to give you some of these tips, then we'll work through some of them so you kind of understand. When you're actually not solving identities, you're proving identities. This is an important concept. We're not solving anything here. It's not going to be theta equals or x equals. We're going to prove that one side equals the other side. So to do that, you have to keep the left-hand side and the right-hand side separate. You'll see we'll give you examples of that. You have to work on the side which seems more complicated. Okay? The idea that's more complicated. In other words, there's more to work with. Sometimes you're going to use identities like you want to change tan to sine over cos, things like that. So a lot of times you change to sine and cos. And then this last one, I said simplify by finding a common denominator. I'm going to say perform operations. Okay, so if you see an addition sign, add. If you see multiply, multiply. Perform the operations that are shown. Okay, so let's try a couple of these. So here is an identity. Okay, if it's an identity, that means it's always true. All right, and we have two parts to do here. The first one is we're going to verify the identity. Okay, verify means show that it's true for this one value. So let's put put 30 degrees in everywhere there's a theta. Okay, and what we want to do is show that these two sides equal. That would mean it's an identity. Now we already know it is an identity, so we know that these will be equal. We just have to be able to show that. Okay, so what do we know in here? Well, the easiest thing to do is I know that cos of 30 is root 3 over 2. Okay, and that means if cos of 30 is root 3 over 2, secant of 30 is 2 over root 3. All right. Are those the same? Well, let's do one more step here. Let's take this and multiply it. Right? That's a distributive property. So you get 2 root 3 plus, what's 2 over root 3 times root 3 over 2? What's 2 over root 3 times root 3 over 2? Can you see that that's going to be 2 over root 3, 2 root 3, which is 1? Okay, so this is 1. And now you can see that the left-hand side equals the right-hand side. And so there, it's true. We verified. Okay, now what we're going to spend more time on is the idea of proving. Proving means we don't have a value. Okay, all we know is that we want to show that this is always true. So I'm going to write secant theta times 1 plus cos theta equals 1 plus secant theta. So this is what we want to prove. Now, if you remember on the previous page, I said keep them separate. That's why we have this line here. Okay, you can't, it's not like algebra where I can say, oh, let's subtract secant from both sides. You're not allowed to do things like that. You're not allowed to treat this as an equation. You have to keep these sides separate. You're only allowed to work on one side at a time, in other words. Okay, so which side should we work on? Well, I said use the more complicated side. Which side looks more complicated? I think you should be able to see that this slide looks more complicated because it looks like there's more to do there. So what do we do? Well, let's perform an operation. Okay, so we're going to get secant theta plus, what is secant times cos? Okay, what is secant times cos? Well, remember I said sometimes it helps to change things to sine or cos. What if I change this secant to 1 over cos, and this cos I will leave? What's 1 over cos plus times cos over 1? That's 1. And now the left-hand side equals the right-hand side. They are the same. And what we do is put two lines like this saying we're done the proof. Okay? So now we have proven that the two sides are equal. We've proven the identity. All right, let's try another one. So first we're supposed to verify for theta is 30. So I'm going to go 1 minus tan of 30 equals cotan 30 minus 1 over cotan 30. So what is tan of 30? Do you remember that that is 1 over root 3? And if tan of 30 is 1 over root 3, then cosine of 30 will be root 3, the reciprocal. Well, are those two the same? Well, let's look over here and find common denominators. So we have this, which equals to root 3 minus 1 over root 3, which equals the other side. So now we have left-hand side equals right-hand side. Okay, let's try proving it. So 1 minus tan of theta, and on the other side we have cotan theta minus 1 over cotan. Okay, how can I show that those two sides are the same? Which side looks more complicated? Well, to me the right side looks more complicated. There's more going on here. So what can we do with that right side? Well, we have a couple of choices here. We could try and change the cotan to cosine over sine. Okay, that works. All right. Another thing we could do is we could take this cotan and divide it into both of these numerators. Okay, there's usually more than one way to prove an identity. Now you're lucky, back when I was in school a couple hundred years ago, you actually had to prove using the shortest method, the fewest steps. But you guys have more than one option. Doesn't matter if it takes a few extra steps. Now, having said that, if you're on step 15 or step 20, you've made a mistake. These should be done in maybe 3 or 4 steps tops. Okay? So let's try this one. I'm gonna call it option A. Let's try and do this by breaking apart this fraction. Okay, like that. Does that make sense? I've taken that denominator and put it into the numerator. And if you do that, you end up with 1 minus, what is 1 over cotan? All right, that is tan. And there you'd be done. Okay? Let's try another method. Let's say instead you decided to write cotan as cos over sine. Now this is going to take us a little longer, but it still works. Okay, if we had this, what we would look at is look at the numerator and we would put that together. To put it together, you need common denominators. And since the denominator we need is sine, 1 becomes sine over sine. And then this would be cos over sine. By the way, if you forget a theta, you lose half a mark. Okay? So on the numerator, I'm going to have cos minus sine over sine all over cos over sine. Now what? Well, remember this is division, right? So what if I rewrite this as multiplication? So here's my numerator, and then I change this to multiplication. So instead of dividing by cos over sine, I'm multiplying by sine over cos. And now this cancels, and I get cos minus sine over cos. And you're saying, wait a second, that doesn't look anything like the left side. Well, yeah, it does. Because what is cos over cos? 1. What is sine over cos? Tan. So therefore, the left-hand side equals the right-hand side. Okay, now you can see that took quite a few more steps. Equally correct. Usually, identities are worth 3 marks. Okay, and the sort of the strategy for marking them is you get 1 mark for, using some sort of identity. So, changing to cos over sine or something like that. So a strategy. Then the second mark is for doing an operation. And then the third mark is kind of that eureka moment, like, aha, I've got it, and then you can finish off the question. Okay? All right, let's try this one. So mixed it up a little bit. This time our first part is to determine the non-permissible values of theta. So we're looking at this equation and saying, what can theta not be? Well, first of all, let's write cotan as cos over sine. You'll see why I'm doing that in a second. And then this is 1 over sine. And this is cos. So looking at this, I divide by sine here, and I'm actually dividing by sine here. And we know that you can't divide by 0. So the question is, where does sine equal 0? What would the values for theta be there? Well, sine is 0 here and here. So that means, okay, the question said, what are the non-permissible values? So theta cannot be 0, pi, and 2 pi. Now, we could keep going, but let's assume that we just mean for 0 to 2 pi. Okay, so if you use any of those 3 values and put them in the equation, you're going to get a non-permissible value. Okay, let's try and prove it now. So the identity is cotan over cosecant equals cosine. Okay, why don't you pause the video for a second and see if you can do this one on your own. Remember, your first step should be what? Which is more complicated? Give it a try. Okay, so the left side looks more complicated. I'm going to write this as cos over sine divided by 1 over sine. Now again, since this is division, I'm going to change it to multiplication, so I get cos over sine times sine over 1. Those cancel. I get cos, which means my left-hand side equals my right-hand side. Done. Okay. Let's try the next one. First thing you're supposed to do is look at what are the non-permissible values. Well, right here, we have to figure out where is 1 plus secant equal to 0, because we cannot divide by 0. So this is where is secant equal to -1. Well, that means the reciprocal is where is cosine equal to -1. And we know that that's here. So theta cannot be pi, because if you have pi, then you'll get 0 in the denominator. Okay? There's one more thing we need to also consider. So I'm going to kind of put this as part A. Part B, you know that secant equals 1 over cos. So this means we also have to consider where is cosine equal to 0. Where is cosine equal to 0? Here and here. That means we have 2 more non-permissible values. Okay? Now I know that's a little tricky, a little hard to think about. There are not a lot of questions on non-permissible values for trig equations, but I think there might be 1 or 2 in the multiple choice. So remember, the question you're always asking yourself is, what is not permissible? In other words, what would make a 0 show up in a denominator? Okay, so this is a denominator, and so is this. Okay, so that's what we looked for. Let's prove it now. Okay, pretty obvious which one's more complicated. What do you think we should do with that? How are we going to make this look like the left side? Well, a little clue. We want to end up with cosine, so why don't we change the secant to cosine? So you're going to have 1 plus cos over 1 plus 1 over cos. Okay, this gives us something to do right away. Look at the denominator. We need to make common denominators and figure this out. So this is going to be cos over cos plus 1 over cos. Okay, so it kind of tells you what to do. Like here, I saw, hey, there's a secant. Got to make that a cos. Then I say, look here. The denominator looks really messy. I can put that together by finding common denominators. Kind of like adding the fraction. So I end up with 1 plus cos in the numerator. And then I end up with cos plus 1 over cos in the denominator. Are you seeing it now? So I have 1 plus cos, that's my numerator. And then instead of dividing, I'm going to multiply by the reciprocal. Cos over cos plus 1. Okay, and the cos plus 1 and 1 plus cos cancel out because 1 plus cos divided by 1 plus cos is 1, and you're left with just cos. So the left-hand side equals the right-hand side, and you're done. Notice I'm only working on one side. Most of the time, that's the better strategy. The second you start working on 2 sides, you'll start getting confused. Okay, so try to stay on one side. All right, so that's kind of your introduction to identities. I'm going to stop there. I'll do these 2 questions on another lesson. Can I get you to do this for homework, please? That worksheet is the worksheet called Identities. It's posted on the My site.